Okay, so we're talking about quilting. So a quilting project, to make a quilt, a quilter is buying fabric in 2 colors. Okay, so they're buying light and dark. Okay, so buying light and dark. So if I were taking notes on this one, I would say light, light and dark. Okay, consider the graphs that represent 2 constraints for the quilter. So explain why 2-2 satisfies the cost constraints, okay, but not the length constraints. So there's 2 different graphs, length constraint and cost constraint. Okay, so we got 2 different inequalities. Okay, so 2-2 is right here on this graph, and 2-2 is right here. What's the difference? What's the difference between those? Say again? It's not in the blue part. So if it's not in the shaded region or the length constraint, not in shaded region, so that means it's not an answer. Okay. For the cost constraint, we can see that it's in that blue piece. So that is going to be included. So it's in the blue region. So it is an answer to the solution for that equation. Okay, so back in Algebra 1, okay, you were taught about inequalities. Okay, so these are inequalities: greater than, less than, greater than or equal to, less than or equal to. Okay, so all of these are inequalities. When you graph it, you graph the line of the equation and then you shade the region depending on which way it's facing. Okay, so that's what you learned back in Algebra 1. So right now we want to find at least one pair of numbers that satisfies both constraints. So that means that it's in that blue region on both of the equations, both graphs. So what point is on both graphs? Then 0, okay. 0, 8, 2. Okay. All right, so you want to find something that they both have that shaded region lying over. Okay, if you graph this on both on the same graph, what you would do is you would have something kind of like this. And that shaded region would fall somewhere in here. Okay, so any number that's picked in between these 2 lines would work. Okay. We're going to go ahead and scroll down. All right, so quilt from start to finish. All right, so there's a lot of good information on here. So I would take notes after you read it kind of through. So to make a quilt, a quilter is buying fabric in 2 colors, light and dark. He needs at least 9.5 yards of fabric in total. Okay, so I'm going to go ahead and write down. We got light and we got dark fabric, and it said light plus dark fabric. We need at least 9.5 yards. Okay, that's what they told us. The light color costs $9 a yard. Okay, so light costs $9 a yard. And the dark color costs $13 a yard. $13 a yard. Okay, the quilter can spend up to $110 on fabric. So up to 110. Let X represent light and Y represent dark. Okay, X represent light and Y represent dark. All right, so now we're going to write an inequality to represent the length constraint. So first of all, we have to identify what numbers deal with the length. Well, they told us that we have light and dark fabric, okay? And they say that we need at least 9.5 yards. Okay, so let's actually write that out as an inequality. Well, X is light, Y is dark, and we need at least 9.5. We could have more, so we're gonna say greater than or equal to, because we could equal 9.5 yards. And that's all you have to do. So now we want to write an inequality that represents the cost constraint. So we're looking at all the numbers that deal with cost. So they told us that it was $9 per yard for light. So that's 9 times X plus it was $13 for dark. So we got 13Y. Okay. And they say up to $110. So you can't spend more than 110. So we're going to say less than or equal to 110. Okay, I'm going to pause. Does everybody understand how to write these two inequalities? That's the first thing that you got to do on almost every single problem in this unit. Okay. Now, are there any other constraints to consider? So for instance, can you have negative yards of fabric? No. So X is going to be bigger than 0. And Y is going to be bigger than 0. Could we have equal to 0 on both of those? No, because think about it. Okay, we're making a quilt with 2 colors. So we have to have at least 1 for both of those. Does that make sense? So we can have like half an inch, but that, or half a yard, but that would be a little silly. But right, so we're going to take all of these inequalities and we're going to go into Desmos. Okay, so we're going to take all of these inequalities and we're going to go into Desmos and we're going to type them in exactly how you're seeing them to graph them. Okay, so watch. We go into here, we go Desmos, not the right one, Desmos, graphing calculator, and we're going to type them over here. So we're going to say X is bigger than 0. We're going to say Y is bigger than 0. Okay, and then we're going to say X plus Y. And when you put this greater than or equal to, you're going to have to use a little keyboard down here. Okay, so greater than or equal to 9.5. I'm going to erase this side so you don't have to like. Okay, so we're going to type that last one in, and that's 9x plus 13y. And we're going to say great or less than or equal to 110. Okay, so we've got a mess over here, right? Okay, so what we're going to do is we're actually going to just take off this y is greater than 0 and x is greater than 0, because we know that if it's greater than 0, we're only looking at this quadrant, right? So we're just going to take those 2 things off so we can actually see what's going on. Okay. Now the solution to these problems. So the solution to these problems is where they actually overlap. Okay. So for instance, right in here, that's where they overlap, right? That's the solution to both of those inequalities. Okay. Now they do meet right here. This point right here. Okay. This point right here is kind of like the best case scenario. So what I mean by that is, like, let's say your parents gave you like 20 bucks to go spend at Walmart, and you buy like a $10 object, and they told you you can't save any of the money for some bizarre reason. Okay. Well, you could just not spend the rest of that $10, or you could go spend it on something else, right? Like getting the most bang for your buck. So this point right here is like best case scenario. We spend as much as we possibly can, and we get as much fabric as possible. Okay. All right, so coming back to our page. So find at least one pair of numbers that satisfies all constraints. Okay, so like I said, if we go back to Desmos, you could pick any number, any points in here that lie in this little shaded region. Now, one thing with systems of inequalities, you're going to have an ordered pair. You're not just going to have an X value. And that's a little different from what we've been working on. So you're going to have an ordered pair. So we would say, whatever this point is, 3.375, comma 6.125. Okay. And what does the pair of numbers represent in this situation? Okay, so let's write down that answer. So we got 3.375, comma 6125. So what this represents is 3.375 yards of light fabric and 6.125 yards of dark fabric. All right, so let's talk about this. Okay, so we have a customer opens a checking account and savings account at a bank. They'll deposit a maximum of $600, some in the checking account and some in the savings account. Do y'all know the difference between checking and savings? Okay, so checking is like what you use like when you go into like Walmart and you have like a debit card and you're like, all right, I'm going to use my checking account to buy things. Savings account means you're putting money away, and that's going to gain some interest on it, and it's just going to kind of rack up a little bit of money. Okay, but they might not deposit all of it and keep some of the money as cash. The bank requires a minimum balance of $50 in the savings account. It doesn't matter how much money is kept in the checking account. So first of all, we're going to state what X and Y are. So I'm going to say that X represents the savings and Y represents the checking account. Now, you could do this the other way around. It doesn't matter as long as you state, hey, X is this and Y is this. Okay, but that's something particular to pay attention to when you're actually doing like word problems on a test, because they might say that X represents checking instead. Okay, so just make sure that you pay attention to how they have it set up. Okay, so let's write an inequality. Well, they say that they're going to deposit a maximum of $600. That means X plus Y is got to be less than or equal to $600. Because they're going to deposit $600 into these two accounts. Okay. Now the bank requires a minimum balance of $50 in the savings account. That means that you have to have at least $50 in the savings account. So that's X is greater than or equal to 50. Okay. But it doesn't matter how much money is kept in the checking account. So we could have $0. So Y is greater than or equal to 0. So those would be the three inequalities that we're going to use. And then what we're going to do is we're going to put that into Desmos and graph it. Okay. Now you could graph this by hand, but I'm going to be honest with you. It's just faster to just throw it into Desmos because it does all of the work for you. So when we go into Desmos, we're going to type x plus y is less than or equal to 600. And then x is greater than or equal to 50. And then y is greater than or equal to 0. And I can't see my little zoom out button because it's all the way over there. There we go. Woo. Okay, so that little triangle piece that we've got going on, that's going to be where our solutions lie. Okay, so it's going to be inside that little triangle. Are there any questions about how to write it, how to define it, and how to graph it? Yep. I just established it. I said X represents savings, Y represents checking. Mhm. Yeah. The only problem that that's going to come up with is like if you're on a test, they will tell you what X and Y are. Yeah. Okay, so what I would like for you to do is try these two problems down here. Okay, and you're doing the exact same things on these, and you're going to turn that one in. Okay. Okay, so after you finish those two, I want you to try this word problem. See if you can get the answer and put it onto your paper when you turn it in.